Okay, guys, good afternoon. Welcome back to my YouTube channel again. This is your host, Santos Capitan Jr. Always wishing you a good day. Guys, today what I'm going to do is to continue my software integration tutorial. This one will be the part 2. Okay, but this time what I'm going to do is to continue the software integration with the Modbus single line communication interface module. Okay, so this one is being used this module is being used to communicate with this MCCB. Okay, so these are the MCCB. Okay, in a project, especially if it's a big project, you might have several motor control centers. Okay, then in a motor control centers, there will be MCCB or main MCCB. Okay, so maybe in a project, you will be asked under electrical specification in the low current section, then maybe you will find there BMS requirement to monitor the real-time values in a specific MCCB. Okay, so that is our scope for today's tutorial. Okay, so how are we going to represent or create a graphics that will show some of the real-time values for a specific molded circuit, molded case circuit breakers. Okay, so now what I want to do now is to show you my system where I created the graphics. Okay, so what I have now is the graphics I have created. Okay, so let me go to the full screen. Okay, so this is my graphics I have presented for the sake of explaining this software integration. Okay, so as I said, you need to create a graphics presentation or the values or real-time values from a specific MCCB. So let's say this is MCCB number 1. Now, in motor control centers, maybe you have several MCCB. Okay. So let's say I'm talking one specific MCCB, which is MCCB 1, electrical room ground floor. Okay. Then this will be my MCCB software integration. Now, software integration will be done through this Modbus single line communication interface module, which is being represented by this. Now, this one, there will be a cable connected to this, okay? So that this module will try to pull the information, okay? So, as a BMS engineer, you will create the graphics representation, okay? But this registers, you might not include it, okay? So, no need to include this one. I'll just include this in the graphics so that I can explain it clearly, okay? So, maybe one of your question is, what are the information that we need to display? Because, of course, there will be so many information in these circuit breakers. Maybe there will be uh, the tens or hundreds of registers that can represent real-time values from these circuit breakers. Okay, so you don't need to display everything. Okay, because if you will display so many information, then it will create so much traffic in your network, in BMS network. Then maybe your system will slow down. Okay, so just pick or select. If there is no, as I said, you have to check the specification. If there is no uh, if there is no specific points that needs to be displayed, then maybe as a BMS engineer, you can select certain points like what I'm having here. Okay, so I'm showing phase voltage or phase-to-phase voltage. So this is a voltage in phase 1 or line 1 to line 2. Okay, so what will be the voltage there? Then phase voltage to line 2 to line 3. Then phase voltage line 3 to line 1. Okay, so you will be displaying it here. Okay, so we are expecting the voltage here will be almost similar. If it is a three-phase voltage, maybe it will show you 413 volts, 415, 415, 415. Maybe there's a little difference. Maybe this one will show you for 414.9 or 415. Okay, but it's almost the same. Okay, then what else? You can display the phase current. Now, in the phase current, phase-to-phase current, you might see some different values. Okay, why? What's the reason for that one? Because maybe in line 1, because this is three-phase, then maybe in this MCCB breaker, they try to connect single phase motor. Okay, so you will not expect that, let's say, you will have the same reading in phase 1, phase 2, and phase 3 for the current. Okay, that is the explanation for that one. Now, for the total power, then for the total power, you can display the total power being consumed in this Mccb. Okay. Now, down below, I have here my registers. Okay. So, as I said in my previous tutorial, part 1, the most important thing that you need to do is to establish good relation with the supplier of this. Okay. Especially if you are going to do the software integration, because they will be the one to give you all the necessary information for you to be able to successfully integrate this Mccb to building management system. Okay, because of course some information will be available in the internet, but the supplier of this, they can always ask from their principal the necessary information or the details, especially the register mappings. Okay, now I have an example of register mapping here. Okay, so as my graphics is showing. So for the voltage, okay, for the voltage, so register 0 if voltage is less than 25. So meaning the register value will be 0 if the voltage is less than 25. Okay. So the register number for phase-to-phase RMS, phase-to-phase voltage 1 to 2, phase 1, line 1 to line 2, that is, you can get that real-time value or the voltage for that one in register 1000. By the way, what is register? Okay, actually, in a computer system, there is also registers. Okay, now actually these registers in computer system are the built-in memory in the microprocessor itself. But this one in this Mccb, there will be registers also. There is like a memory location wherein they will store the value. Okay, so the register number, okay, is 1000. So you will be needing this information so that you will be able to display the real-time value of phase voltage line 1 to line 2. Okay. So what will be the unit is voltage. So read right. You will just read the information. Okay. That it will be times 1. So meaning whatever is being displayed there, that will be the value. You don't need to multiply it with any uh, multiplier. Okay. Now the type is integer 16 bit integer unsigned. Okay, so this one is also important. Okay, so the range is 0 to 850. Now actually the low voltage is around for 380 or to 600 or something like that. Okay, so anyway, the range is 0 to 850. Okay, it depends on the power distribution. Okay, so 1000, register 1000 for V12 or phase voltage, line 1 to line 2, then 1001, 1002 for V23 and V31. Okay. Now, how about the current? So because I want also to display the current here. So current, now the register is 1016. Okay. That one also the unit is A or ampere. Then 16 bits integer, then unsigned. Okay, then the range is this one, 0 to times log, natural log. Okay, now anyway, it will display there whatever is the reading of the current being drawn from this phase 1. Okay, because we are using 3 phase. Okay, so as I said, there might be difference reading here. So you will not expect, for the voltage, you will expect almost the same reading. If it is 415, this one also will give you 415. Okay. Now, because if one phase is showing a very low voltage, then there's a problem with the distribution, power distribution. Okay, then the current, as I said, if this Mccb, they connected a single phase motor, then one of the phase might show a higher reading, okay, than the other. Now, here, total power. Now, I have here the active power because we have the active, then reactive, then there's another kind of power. But here, you have to as I said, you have to check the specification. If they will say display the active power, as you can see, you can show also the active power on page 1, active power in page 2, active power in page 3, then the total active power. Okay, so maybe I'm just showing here in my graphics this total power, total active power. That will be the total active power. So the register number is 137. Then there is a multiplier here times 10. So let's say you get a value of 100 times 10, that will be 1000 kilowatt. Okay, so the unit is kilowatt. Again, now the type here is integer 16. Okay, okay, then okay, so this is how you are going to get the information from the Mccb through this Modbus interface. Okay, now let me, okay, so view. Okay, I will show you, I will go to full screen. I will show you how I'm going to, okay, now here, I have here the MCCB. I have shown you already how I tried to add this Modbus single line interface module. Okay, so I'm just talking of one. Okay, now if it is already added, you can check the properties. So what is important here is you uh, check the status. If it is already online, then the device address. Now I've shown you already, I set it to 4. Okay, now what is important, it should be online. Okay, now once these are okay, then you can create the points based on my graphics. So my graphics, okay, let me open the graphics. Open a new window. Okay, so the graphics here, I have base voltage 1 to 2, 2 to 3, and 3 to 1. Okay, so here I said this one is voltage. Okay, let me, okay, so for monitoring or if you are working on it, you can add a column, the value. Okay, so B1 to 2, that will be the phase voltage, phase 1 to line 1 to 2. Okay, the value I have 0 here because my single line Modbus communication interface module is not connected to a MCCB. Okay, so I'm just showing you how are you going to do it. Okay, now here you can add the new Modbus point. Okay, so Modbus point, again, this will be an analog value. Okay, because it is a continuing or varying quantity. So analog input point. Okay, so I will say here, since I already have this B12, so I will just say this one is B. Okay, B23. Okay, so that is the voltage. Okay, create. Okay, now again, we need to check the properties of this. Okay, now the pole register, what will be the pole register? Okay, so let's check the pole register. So the pole register will be, okay, for B23 is 1001 and 1002. Okay, uh, okay, so let me go back here. So the pole register will be 1002. Okay, save it. Okay, then go back to list view. Okay, now this one you can copy this. Just control, just to so that you can document your work. Okay. Okay, so let me just create some of the points. So new. Okay, again Modbus point. Again analog here. Okay, now let's see if we can copy this. Maybe we can copy this. Okay, I will try to copy this. We will see so that we will not go the long. Okay, paste. Okay, we can copy it. Okay, so this one just try to rename it. Rename. Okay, this way it is more easy to. So this one will be line 3 to line 1. 3 1. Okay, then change this to 1. Then, okay, go to the properties. You have to change this register. Okay, so 3, save. Okay, so let me create another here for the phase voltage. Okay, bear with me. A new Modbus point. Okay, again, that will be our ampere 1, 2. Okay, create. Okay, so this one, let me put some phase voltage. Okay, let's say this is phase current. Okay, so A1, 2. Okay, then let's see, let's change the properties of this one. Now, first, let's check the what will be the call register for the current. Okay, it starts at 1016. Okay, it starts at 1016. So let me go back to mine. Okay, start at 1016. Okay, 1016. Okay, then 1016. Let me go back there. So I have that one. Now I will try to copy so that it will be okay. So that just bear with me. Paste. Okay, rename. This one is A23. Okay, then go to the properties. It says here 17. Okay, then go back to list view. Okay, then let's copy this. Control C. Let's paste this one here. Okay, and again, let's copy this. Copy, paste. Okay, so bear with me, guys. Rename. Okay, so this one will be base current 3 to 1. Okay, then let's copy this. Control C. Okay, Control V. This one will be 3 to 1. Okay, now one more. We need to create. Okay, let me go back to my list. Okay, now let's change the properties within the one. Okay, 16, 17, now it will be 18. Okay, then again, another point. Now this time, let's create another point. This one is before the total power. So this is total active power. Okay, actually, you can display also the base power. Okay, but no need. As I said, you need to uh, you don't need to display everything. Okay, now this one, what will be the description of this? Active total power. The same, maybe total. I will change this one because it's redundant. Rename. I will say this one is total AP. Active power. That will be. I will just say kilowatt. Okay. Now let's see what is the address for that one. I mean the register. So for the total, this one will be the here is 1037 for the total active power. Okay. So view, let's go. Okay. So 37, 1037. So here, so let's go to the properties. Properties. Then let's change the register number. That is 1037. Okay, so you can see here that is 16-bit unsigned. Okay, so you can change it here. It is 16-bit unsigned or whatever is in the detail. Okay, because if you will not use the correct data type here, you might not be able to display the correct value. Okay, here if you will check, let's go to the properties. Let's change. Okay, so 16-bit unsigned. As you can see in the because you can There are so many here. There is an Indian here, I think. Okay. Okay. So 16-bit unsigned. Okay. So that is correct because that is being reflected uh, in our register details. Okay. So this is 16-bit unsigned, 16-bit integer unsigned. Okay. So okay. So guys, once you save this information, then if your interface module is connected to the Mccb and if there's power, then it will display the values here. Okay, so I don't have a value here because uh, I don't have the Mccb. Now, what is missing here is you need to map these graphics. Okay, so how are you going to do that one? Come here, then you will say edit bindings. I will just show you one binding. Okay, AMP 12 for the AMP. Then you go here, you look for your Modbus interface. Where is my Modbus interface? Okay, this is my Modbus interface. Then that is my MCCB. Then this is my AC. Okay, so ampere 1, 2, 3, ampere 2, 3, ampere 3, 1, total power. So how it is easy to do the bindings, okay? So save it. No, cancel. Save it. Then it should show. Okay. Now, guys, you will tell me why. What's the problem? Because my module is not really communicating to the MCCB because there is no MCCB. Okay, that's why you will see here this X, meaning there is no communication. Okay, from the uh, MCCB, not from this one. Okay, because the communication is just like my automation server is just passing from here, but actually it's getting the value from the registers which I specify here. Okay, but since my communication port B is trying to get or trying to pull data and it's not getting any value, that's why I have this one. Okay, so anyway, it's normal if there is no communication from my automation server passing here and getting the information. It's normal, no issue. Okay, so guys, to wrap it up, what I have shown you here is the creation of the graphics wherein you will display what is being required in the electrical specification, what needs to be displayed in the PMS. Okay, so I just added this register mapping here just to show you how are you going to do the actual integration. Okay, so again guys, we have done MCCB software integration through Modbus single line communication interface module, which are getting information from the respective MCCB. Okay, then again, you don't need to display all the information in the registers of this MCCB because there might be hundreds of registers there. You don't need to do that one. The reason for that one is you don't want to create so much traffic in your BMS network. So once again, if you are new to my channel, please support my channel by subscribing. You can like, share, and put your comments if you have one. Then you can tell your friends about this tutorial. That this tutorial will be complete. So bear with me. I will try to complete this tutorial to help new engineers, okay, who are wishing to join building management system or building automation, or those engineers who are wishing to join MEP company, mechanical, electrical, and plumbing company. So before I will end this tutorial, let me say God bless us all. Let's all be safe and bye for now.